Today we're going to be talking about the nature of matter, and you might be asking yourselves, why do biologists need to understand the chemistry of life? Well, just as buildings, as your book says, are made up of bricks, of glass, of steel, living things are also made from chemical compounds. And not only that, organisms will use substances in the air, in food, and in water to carry out chemical reactions. That is why over the next few weeks we are going to be studying atoms, elements, compounds, water, carbon compounds, macromolecules, chemical reactions, and enzymes. Since you studied this last year, we are just going to do a quick review. Now, remember, when we look at the objectives, you must remember that all living organisms are made up of elements which are used to build the larger molecules of life. And by the end of the lesson, you should be able to identify the components of an atom and how atoms can be bound to each other. But let's go back to the first image. What do we see here? Think a minute of the elements and compounds that are represented in this image. I'm sure some of you already said, well, hydrogen and oxygen are combining here to form water. Yes, try to find some more elements, some more compounds. When we look at this slide, we think about atoms. We know that atoms are the basic unit of matter, of course, and that atoms are made up of protons, neutrons, electrons. You know, of course, that protons are positively charged, you know that electrons are negatively charged, and you know that neutrons don't have an electric charge. In this figure, you can see that this atom has 6 protons, has 6 electrons. So atoms kind of tend to have equal number of electrons and protons, and when they have equal number of both, then they are electrically neutral. In this slide, we are looking at an element, and you know the definition of an element. So we are going to be asking, what is the atomic number of this element? Of course, it's 6. And you know that the atomic number is given by the number of protons in the nucleus of an atom, and that different elements have different number of protons. When we talk about isotopes, let's try to remember what the definition of an isotope is. Okay? Remember that an isotope is an atom of the same element, but it differs in the number of neutrons it contains. Now you must remember that since they have the same number of electrons, all isotopes of an element have the same chemical property. Now, if you look, for example, at carbon-14, you can see that it has more neutrons than protons. So what does that mean? It means that its nucleus is unstable, so carbon-14 will tend to break down at a constant rate over time. So these are called radioactive isotopes. Carbon-14, which is radioactive. Now, the radiation, of course, can be dangerous, but you will find later on that radioactive isotopes have other uses, and that scientists use them for other things. Here we have chemical compounds, and of course you know what a chemical compound is, and you also know that they are usually shown using a chemical formula. Okay, let's look at this slide about ionic bonds. Okay, remember subatomic particles, protons, electrons, neutrons. Now let's look at sodium. Okay, how many electrons does sodium have? Of course, it has 11. Okay, so what is its overall charge? 0. Now let's look at chlorine. How many electrons does chlorine have? 17. So what is its overall charge? 0. Now you can see that a sodium atom easily loses its one electron, and chlorine easily picks up this electron. So this will change the number of electrons in each atom. If we look at the diagram on the right, sodium now has 10 electrons and its overall charge is 1. And chlorine now has 18 electrons and its charge is -1. So when positive and negative charges attract, the atoms form an ionic bond. So that is, an ionic bond is when one electron is transferred from one atom to the other. So if an atom gains an electron, that it has a negative charge, it becomes an ion. And an atom that loses electrons becomes positively charged and becomes an ion. Now we have covalent bond. Let's look. This is the water molecule. Everybody knows the water molecule. So hydrogen has 1 proton. So how many electrons would it have? 1 also. And oxygen has 8 protons. So how many electrons would oxygen have? 8. Okay, so if each hydrogen has 1 electron and oxygen has 8, how many electrons in total, as it says in the figure? 10. Okay, so in this image we see that electrons are being shared between oxygen and hydrogen to form covalent bonds. So these are covalent bonds, and we can remember ionic, opposite, attract, and covalent, sharing. Okay, the last slide tells us about the van der Waals forces. Okay, so how could weak intramolecular forces between the gecko's feet and the wall prevent gravity from pulling the gecko off the wall? You're going to read about this and you're going to answer some questions about this in the Google Doc document. And the last slide is one that you're going to be working in a Google Doc. You're going to compare and contrast ionic bonds and covalent bonds, and you're going to be using a Venn diagram. Thank you. Let's go on and let's work in our Google Docs, please.